Okay. Uh, Good evening, everyone. This is my third lecture for three-dimensional geometry. So, three-dimensional geometry, third lecture. So, basically, here we will be. I will speak about plane. So, starting with plane. First of all, we should understand what do we mean by a plane. So basically, a plane is any we can define plane as a surface. Plane is a surface. Okay. Any surface or any two-dimensional uh, two-dimensional domain, we can say. Two-dimensional domain is a plane. Like, for example, floor or wall or ceiling. Okay, all these are examples of a plane. Okay, so now we come to the point where we have to understand how we need to we can find the equation of a plane. Okay, so I'll just rub this part. Okay, so okay, so how do we write the equation of a plane? Okay, so for writing the equation of a plane, suppose we have this equation uh, and we have the normal. This is the normal for the plane. Okay, this is the normal. Suppose the normal vector is a I cap plus b j cap plus c k cap. Okay, so the normal vector the vector which is normal to the plane, that vector is a I cap plus b j cap plus c k cap. Okay, and we have any point P which is lying in the plane, say x1 y1 z1. Any point P is lying in the plane, say x1 comma y1 comma z1. So how we can write the equation of plane? So what we can do here, we take a point r, variable point r, say x comma y comma z. We take a variable point r, say x comma y comma z. Now this vector PR vector is lying in the plane. PR vector lies in the plane because it is formed by 2 points which is lying in the plane. P point is also lying in the plane and R point is also lying in the plane. Obviously, so PR vector will lie in the plane, and this vector, the normal vector, suppose this vector is say n cap. N cap, which is the normal vector, is perpendicular to this plane. So the angle between the plane and normal vector is 90, right? So we can say PR vector is also perpendicular to normal vector n vector. So we can write PR vector dot n vector is equal to 0. So PR vector we can write down by subtracting the position vector of R minus position vector of P. So x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap. So this is the PR vector and dot n cap. N cap is n vector is a I cap plus b j cap plus c k cap. So this is equal to 0, right? So now if we take the dot product, whenever we take the dot product, we multiply the I cap coefficient with the I cap, j cap with the j cap, and k cap with the k cap. Therefore the equation of the plane will be a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. A into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. So this is the equation of the plane. This is the equation of the plane. Right. So like that. Okay, so this is where we can say that when x1 comma y1 comma z1 is the point which is lying on the plane and a, b, c are the direction ratios of the normal to the plane, then equation of the plane I can write as a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. Right. So let's continue. Now this was the Cartesian form. Now I will explain the vector form of equation of a plane. Vector form of equation of a plane. So suppose we have a plane like this, and n cap is a unit vector which is perpendicular to the plane. N cap is a normal vector which is perpendicular to the plane. Okay, so in that case, if we have a point P, R vector, and I have a point say Q which is A vector. So what we can do, we can form the PQ vector which is lying in the plane. PQ vector lies in the plane. So PQ vector is perpendicular to n vector, right? N cap. PQ vector is perpendicular to n vector because both points P and Q lie in the plane. So PQ vector is perpendicular to n vector. So again we can say that PQ vector dot n cap is equal to 0. So I can write this as R vector minus A vector dot n cap is equal to D is equal to 0. So on simplifying we get R dot n cap is equal to A vector dot n cap, which is some scalar value, say D. So this is the equation of the plane in vector form or vector notation. This is the equation of the plane in vector form or vector notation. R vector dot n cap is equal to A vector dot n cap, and then A vector dot n cap we can write this equal to D, where D is a scalar quantity. D is a scalar quantity. Okay, so let's do one question related to this. Let's do one question. Suppose we have a plane like this and we have a point P, say 1 comma 2 comma 3, and there is a normal whose direction ratios are 3, 4 and 5. So how do you write the equation of a plane? So in that case we can write the equation of plane using Cartesian form. We take a point R, say x comma y comma z, then obviously PR vector will lie in the plane, and 3 comma 4 comma 5 is the direction ratios of the normal. Therefore PR vector is perpendicular to the n vector, where n vector is nothing but the vector formed by the direction ratios. So 3i cap plus 4j cap plus 5k cap. Therefore we can say that PR vector dot n vector is equal to 0. So I can write x minus 1 into 3 plus y minus 2 into 4 plus z minus 3 into 5 is equal to 0. So the equation of the plane will become 3x plus 4y plus 5z minus 3 minus 8. So minus 3 minus 8 is minus 11, minus 11 minus 15 is minus 26. So that minus 26 will go on the right hand side and become plus 26. So we get the equation of plane like this: 3x plus 4y plus 5z is equal to 26. So this is the required answer. So I hope you liked this video, and we'll be doing more problems related to plane in the upcoming videos. Okay, thanks for watching.